Welcome to my channel. In this video, we are going to discuss about the three important problems from the class B power amplifier. So in the previous video, I posted the three problems for the class A power amplifier. Okay, so in class A, there are two class A amplifiers there. One is series feed class A and another one is transformer coupled class A. So the three problems we discussed in the previous video. If you want to learn that video means I will give link for that video in the description box. You can refer it. Okay, so now we are going to discuss about the class B power amplifier problem. So in class B also there are two types. One is push-pull class B amplifier and another one is complementary symmetry push-pull class B amplifier. So from that amplifier we are going to see the some problems. Okay, so the first question you see, a single transistor operates as an ideal class B power amplifier. So usually the push-pull amplifier and a complementary push-pull amplifier is constructed using two transistors. Okay, since you know the working principle of class B amplifier, the conduction angle is conduction angle is 180 degree. That is during positive half cycle of input only the transistor it will in on condition. Okay, so that's why in order to get the complete output we have to use two transistors. But here the given question is the ideal class B amplifier it uses only one transistor. Okay, then if the DC current drawn from the supply is 25 milliamps. Okay, so what is the DC current used in that class B amplifier is 25 milliamps, and the question is calculate the AC power delivered to the load. Okay, if the load is 2 kilo ohm. Okay, this is the question. So only one thing we have to find out, what is the AC power delivered to load, that is PAC. Okay, the AC power delivered to load we have to find out. The load is 2 kilo. So first one you have to note down the given data. So for a single transistor, transistorized class B amplifier, the three data given. So what is the first thing? The first thing is this 25 milliamps. 25 milliamps is the DC current. Okay, IDC, DC current given. Then the load is 2 kilo. Okay, so this two data is given. So our question is we have to find AC power delivered to load. So what is the AC power supplied to the load RL? This is our question. Okay, this is amplifier. So what is the AC power supplied to the particular load we have to calculate. So you know the AC power formula. So what is the AC power? The AC power delivered to the load is calculated by PAC equal to IRMS square into RL dash. Okay, so this is the AC power supplied to load. So here in order to find out this AC power, so we need the IRMS. What is mean by IRMS? IRMS said to be root mean square current value. Okay, in the collector terminal. So the IRMS can be written as IM by root 2. Okay, and what is IM? IM is the maximum value of the collector current. So in order to find out this AC power delivered to load, first we have to find out this current. Okay, this maximum current flowing in the load we have to find out. So that the current, the maximum current flowing in the load is calculated by, so you see that maximum current. So here we are using the class B amplifier, the class B amplifier with a single transistor. Okay, so the class B amplifier, you know, the class B amplifier operates for the conduction angle is 180 degree. So that's why we will get the waveform like this. Okay, during positive half cycle, the wave will come. During negative half cycle, the output is 0. Then during the next positive half cycle, the wave will come. Okay, so that's why the average, the DC current, it is nothing but. Okay, so what is the DC current for this type of half-wave rectified signal means? The DC current is nothing but the average value of this collector current. Okay, so this is the collector current flowing in the flowing in our class B amplifier. So this IC value, okay, the maximum value, the IDC is nothing but it is the average value of this half-wave waveform. Okay, so what is the average value of this half-wave waveform means IDC equal to IM by pi. Okay, so this is the formula. So here IDC is given. Okay, the DC current flowing is given. It is at 25 milliamps. Okay, and from this equation, our aim is to find out this IM. Okay, so you just rearrange this equation. So if you are rearranging, IM equal to IDC into pi. Okay, so what is the IDC? The DC current given us 25 milliamps. So 25 into 10 to the power minus 3 into pi. So the answer is 78.54 milliamps. Okay, so this is the IM value. So once you calculated IM value, so you substitute this IM value in our AC power delivered to the load formula. Okay, so you see, so the AC power delivered to the load, it is given by PAC equal to, what is the formula? That power in the collector terminal, the load is nothing but the current flowing through that one, the whole squared into the load resistor. Okay, so that's why IRMS squared into RL. So here IRMS nothing but IM by root 2. So IM value just now we calculated 78.54 milli. Okay, so you substitute the IM value here. Okay, so IM divided by root 2 the whole squared into load resistor in our problem is given as 2 kilo ohm. Okay, so you solve this. So you can get the answer 6.168 watts. Okay, so this is the AC power supplied. Okay, AC power delivered to the load. Okay, this is the one question. Okay, so this is the first question. So in that question, the two data given, one is the supply current. Okay, collector DC current from the supply is given, load value given. So what is the power delivered to load? Okay, so the power delivered, in order to find out the power delivered, you should first calculate IM. Okay, so the IM value is calculated from the IDC formula. So here the IDC, the DC current is nothing but the average of this half-wave rectified signal. So the formula is IDC equal to IM by pi. So from that you just calculate IM value and substitute here, you can find the answer. Okay, so this is the first question. And the second question, you see, for a class B amplifier. Okay, so for a class B amplifier providing 20 volt peak signal to 16 ohm load. So load is 16 ohm, 20 volt peak signal, operates on a power supply of VCC equal to 30 volt. Okay, supply is given. Determine input power, output power and efficiency. Okay, so here supply voltage given, load given, and peak value, the VM. Okay, the peak value of the output VM is given. So we have to find input power, output power and efficiency. Okay, so the first one, you note down the data. The supply voltage VCC 30 volt, peak value of output voltage, so VM. Okay, peak value of output voltage means this is the one. Okay, this VM is 20 volt and the load resistance is 16 ohms. Okay, so the three thing we have to find out. First one, input power. Okay, so what is the input power supplied by this class B power amplifier? It is a PDC or Pin. Okay, input power, so it is mentioned as Pin, or it can be referred to as a PDC. Okay, so what is the PDC value? The DC input power, it is nothing but it's a product of VCC into IDC. Okay, so that's all, VCC into IDC. So where VCC given, but IDC is not at all given. Okay, the DC current is not at all given in this problem. In previous problem, IDC given. So we have to find the IDC value. So what is IDC? This is the class B power amplifier. So for class B power amplifier, the output waveform is like this half wave rectified signal. Okay, since the waveform, this class B amplifier, the transistor is conducting only for 180 degree. So that's why the DC current, the average value of the DC current, it is IDC. So IDC equal to IM by pi. Okay, so here we have to find out IM. Okay, so in order to calculate IM, here VM is given. Okay, so the peak value of voltage is given 20 volt and the load resistance is given. So using the VM value and the RL value, we can calculate the maximum current. Okay, so according to Ohm's law, the maximum current is equal to the maximum voltage divided by the resistance. Okay, so what is the maximum peak voltage given? 20. What is the load resistance given? 16. So 1.25 amps. Okay, then you substitute this IM value in IDC formula. Okay, so substituting IM in IDC formula, so you see IDC equal to IM by pi. So 1.25 divided by pi. So the answer is 0.3979. Okay, so once you calculated IDC, so you substitute this IDC in our input power formula. Okay, so what is the input power formula? The input DC power is equal to multiplication of VCC into IDC. Okay, so the input power. Okay, so input power PN is equal to VCC into IDC. So VCC 30 volt. IDC is 0.3979. Okay, so if you are multiplying, you can get the answer is 11.93 watts. This is the input power. Okay, so one thing, the first data calculated. Similarly, the second question is to be how to find output power. Output power means the AC output power delivered to load. Okay, so the AC output power, it is nothing but here what are the data given means here load value. Okay, so load resistance given, peak output voltage is given, but output current is not at all given. Okay, so in the previous problem, okay, so in previous problem you see the output current, the IM value, so we know we can substitute IM by root 2 the whole squared into RL dash. Okay, so here, so we may use one more formula for the PAC in terms of VRMS into IRMS. So the output power, output AC power is nothing but the product of VRMS into IRMS divided by 2. Okay, so what is VRMS? So you know VRMS is nothing but VM by root 2. IRMS is nothing but IM by root 2. Okay, so into 1 by 2. So here VM and IM. So if you are multiplying 2 root 2 means, so it is 4. So VM IM by 4. So here what is VM? VM is given. Okay, in our problem, the VM value is 20 volt. And IM just now calculated 1.25 amps. So 20 into 1.25 divided by 4. So the answer is 6.25 watts. This is the output power. Okay. So once you calculated the input power and output power, then the third one is a efficiency. So efficiency, it is nothing but eta. It's a ratio of AC output power delivered to load divided by DC input power applied to the class B amplifier. So P naught AC divided by P in DC. So what is the P naught? 6.25 watts. What is the P in DC? 11.93 watts. So if you are dividing 6.25 divided by 11.93, and if you want to convert the efficiency into percentage, you just multiply with 100. So the answer is 52.3 percentage. Okay, so for this class B amplifier, the efficiency is 52.3 percentage. Okay, so this is the second question. Okay, so from the given data, peak voltage, load resistance and VCC, we calculated the input power. Input power is nothing but VCC into IDC. Okay, so the IDC is calculated by IM by pi. And in order to calculate IM, we have to use VM by RL is nothing but IM. Okay, so this is the input power, and output power is nothing but VRMS, IRMS divided by root 2. So using that formula, you just calculate. Then the ratio of the AC output power to the DC input power, it is called as a efficiency. So this is the second type of question. And the third question, so you see in an ideal class B push-pull amplifier. Okay, so push-pull amplifier means, so here this push-pull class B amplifier is constructed using 2 transistor. Okay, 2 transistor of same type. VCC is 20 volt and N2 equal to 2 into N1. So this is the transformer coupled class B push-pull. Okay, so here the transformer turns ratio is given. N2 equal to twice N1. That is number of turns in the secondary winding is equal to the twice the number of winding in the primary winding. Okay, and RL is 20 ohm. Okay, these are all the given data. Find the following. The first one is output signal power. Okay, output signal power P naught, maximum output signal power we have to calculate. Then the second one, collector dissipation in each transistor. So what is the power dissipation collector power dissipation in the collector of each transistor we have to find out. Then the next one, PC under full condition. Okay, so PC, the power at the collector in full power condition we have to find out. Then PC max, also find PC max. Okay, so these are all the things we have to find out. So first one, for an ideal class B push-pull amplifier, the three data given. One is supply voltage, VCC given, the turns ratio, okay, transformer turns ratio N2 equal to 2 into N1. Okay, for example, if number of turns in the primary is 10 means number of turns in the secondary is 2 into 10, 20. Okay, this is the turns ratio, 1:2 ratio. 1:2 ratio, the transformer winding is there. Load resistance 20 ohms. So these are all the given data. So what is the first question? First question is we have to find out output signal power. Okay. What is the output signal power for class B push-pull amplifier? So the maximum output signal power of class B push-pull amplifier is PO max is equal to VCC squared divided by 2 into RL dash. Okay, where RL dash is the effective load resistance. Okay, so here we are using the transformer, that is in output the load is connected with a transformer. Okay, so that's in secondary winding we are connecting our actual load RL. Okay, the collector in transistor collector we connected the primary winding. So because of this load, here in primary winding some load resistance effect is there. It is called as a effective load resistance. It is said to be RL dash. Okay, so you know the expression for output maximum power for the class B push-pull amplifier. It is PO max is equal to VCC squared divided by 2 into RL dash. Okay, VCC given, RL dash we have to find out. So what is the effective load resistance means? The formula is that N1 by N2 the whole square into RL, where N1 is the number of turns in primary, N2 is a number of turns in secondary. So here what is the data given? N2 equal to 2 into N1. So you substitute instead of N2, you substitute 2N1 here. So N1 by, instead of N2, 2N1 to the whole square into RL. What is RL? RL is 20 ohm. So here N1 cancel. So what is the thing? 1 by to the whole square. So 1 by 4. Okay, it is 0.25 into 25 ohms. So the effective load resistance is 5 ohm we calculated. Okay, so RL dash calculated. Then you substitute this RL dash and the VCC value in a maximum output power formula. So what is the maximum output power for push-pull class B? VCC squared divided by 2 into RL dash. Okay, so what is the supply voltage given? 20. So 20 squared divided by 2 into effective load is 5. So if you are calculating, the answer is 40 watts. So this is the maximum signal power at the push-pull class B amplifier. Okay, so this is the first question. Then the second one, the collector dissipation in each transistor. Okay, so what is the collector dissipation in each transistor of class B push-pull amplifier means? That expression is that. So you see, this is the maximum collector dissipation in each transistor is given by PC equal to 2 by pi VCC into VM divided by RL dash minus VM squared divided by 2 into RL dash. Okay, so this derivation already we derived in class B push-pull amplifier. Okay, so you just see the formula, 2 by pi VCC into VM by RL dash minus VM squared divided by 2 into RL dash. So here VCC, you know, RL dash just now calculated. Then VM. What is VM? VM is a peak voltage of peak output voltage. Okay, so VM is not all given in our problem. So we have to find the VM first. So what is VM means? The VM is nothing but the supply voltage divided by the turns ratio. So what is the turns ratio here given? 1:2. Okay, so the VM is nothing but VCC divided by 2. So that's why it is 10 volt. Okay, so the maximum peak voltage is 10 volt. So then you substitute VM value RL dash value, VCC value in our above formula. So you see the collector power dissipation is 2 by pi 20 into 10 divided by 5 minus 10 square divided by 2 into 5. So 15.46 watts. So 15.46 watts is the collector dissipation in each transistor. Okay, so the class B push-pull using 2 transistor. In each transistor, this much amount of power is dissipated. Okay, so this is the second question. And the third one, maximum peak dissipation we have to find out. So the maximum peak dissipation. So this is the actual collector dissipation. So the maximum peak dissipation is PC max is equal to, the formula is 2 divided by pi squared VCC squared divided by RL dash. Okay, so this is the actual power dissipation in each transistor collector. So the maximum peak dissipation formula is 2 by pi squared VCC squared by RL dash. Okay, so you substitute, so 2 into 20 squared divided by pi squared, RL dash is 5, so 16.21 watts. So this is the maximum power dissipation. This is the actual power dissipation in each transistor. This 15.46. So the maximum, how much dissipation it takes place means it is a 16.21 watts. Okay, so these are all the things behind the class B power amplifier. Okay, so in this class B power amplifier, we calculated the input power, output power, efficiency. Okay, so what is the output power delivered to load? Then for push-pull amplifier, we solved one problem. Okay, what is the maximum output power, and what is the collector dissipation in each transistor, and what is the maximum power dissipation in transistor. Okay, so all these things we solved. Okay, so you just go through the formula and you solve this problem. Okay, so thanks for watching my channel, and please subscribe my channel for more videos if you want to learn the remaining problems. Okay, so from feedback amplifier, then oscillators, tuned amplifier, and the DC to DC converter problem, clipper clamper. So all problems are available in my channel. There is a playlist is there in the name of circuit analysis MCQ. So in that playlist, all videos are available in order from unit 1 to unit 5. Okay, so thank you. We will meet in the next video with one more problem.